All right, everyone. Thank you so much. My name is Mike Marco. I'm the Senior Director of the Applied Social Media Lab at the Berkman Klein Center. Really pleased to welcome you here today and to welcome Dave Willner, who is the co-founder at Zentropy, a company behind COPE, a best-in-class small language model capable of accurate and, most importantly, steerable content classification, which is really exciting. He was previously a non-resident fellow at the Stanford Cyber Policy Center, and he worked in various roles in industry, including head of trust and safety at OpenAI, head of community policy at Airbnb, and head of content policy at Facebook. So we're very pleased to have Dave here. He's an affiliate in our community, and we're so pleased to welcome him. Dave.
Hi, folks. It's good to be here. Nice to see everyone. I was here and gave a talk, I think about a year and a half ago, about why I thought that we should expect that large language models would change the way we did content moderation pretty substantially. And in a lot of ways, you can see this talk as a follow-on to that one. I'm going to do a little bit of sort of previously on the next episode because I'm in some sense in dialogue with myself in the past, and then dive into some of the stuff that we ended up working on in the last year and a half, because when I gave that talk, it was very much a sort of, this is totally going to work. Trust me, it's going to be a big deal. It's definitely going to be helpful. Here's all the reasons why you should expect me to be right about this, but there wasn't a lot in the way of actual demonstrable proof. My co-founder and I spent some time at Stanford after that talk working on some proof and have since then founded a company based around that proof and done some more work. So I'm actually going to get into how we did some of what we did, well, what we did, how we did some of what we did. And then I'm also going to demonstrate some of that live for you so you can see what I'm talking about in a little sort of tactile, hands-on way before we get into interview and some questions. Is this thing? There we go. Okay, so this is the sort of like previously on the setup argument for why we should expect this to work. Traditional content moderation does not work well. It is not really ever automated, and when you use humans to do it, it is terrible. And there's a couple of different reasons for this. You can get really deeply into them, and that could itself be an entire 20-minute talk. But basically, the way that we produce content moderation decisions at scale is by regimenting a ton of human labor. That labor is very hard to regiment. It involves putting people in miserable circumstances looking at awful things. This was my first job. I can say that from firsthand experience. And on top of it, folks are not very good at doing it. And this is not a, oh, the folks doing it are not very good at doing it. It's no humans are very good at doing this because in addition to being quite difficult cognitively, it's kind of boring and very stressful and involves coping with keeping a lot of text in your head while you're making live decisions under pressure, which is just not an environment that is conducive to super high quality decisions. And then all of the automation we have is just trained on the mediocre output of that sort of miserable process that we are using to power all of this. And any of the automation that we have historically had, the sort of black box machine learning models, produce decisions that are inherently inexplicable. They're not producing an argument as to why content does or does not meet a given policy. They're producing a prediction about what the humans would have said if you had bothered to ask them what they thought about this content under the policies that you'd written. So even when we try to automate, the automation is meaningless. The whole thing is sort of a shambolic mess. It was the best we could do, but it wasn't great. Now, I stood here a year and a half ago talking about how LLMs were going to fix this, and I still believe that's true, but the stock foundation models have a number of problems. When you try to use stock foundation models to do either content moderation or policy writing, you end up swimming upstream against basically their strongly held priors. The companies that release these models do safety training on them. This is a good thing. We're glad that they do that. But what that means is that they are essentially inculcating the model through reinforcement learning with a very particular perspective on what a bunch of the subject matters that you would want to deal with in writing a content policy or classifying against a content policy mean. And that means that if you need something specific or idiosyncratic, either because you are, say, working for a very particular community that's got a particular set of norms, or even you're just trying to build an escalation queue where you're only looking for a subset of some problematic activity because you want to look at that first or deal with it faster, you're going to have a hard time if you try to use stock language models to do this. I can say this with confidence because this was the first thing that we tried during our fellowship at Stanford. Didn't work well. So you get something closer to a vibe than you get an actual strict policy text following. If you try to do something like carve out protected categories that you might typically expect to be on a list of protected categories in a hate speech policy, the stock models will not follow you there. If you try to expand to include some new or interesting group, often they won't follow you there as well. They're too anchored in their priors. Okay, so what do we do about this? When Samit and I started at Stanford, we were trying to figure out, okay, can we fix this through better policy writing? And we published some articles about that. The answer is like kind of yes, but the policies you end up with are very painful. They're very repetitive. They're not super great for humans to read because you end up having to repeat yourself over and over again to essentially bully. People call it prompt engineering. I think of it as sort of model bullying, to bully the model into the behavior that you want it to show. Like kind of. So we ended up asking ourselves the question, okay, how could we actually train for this behavior, this responsive policy following behavior that we wanted to see? And the answer is that essentially you have to, it's this, and I will get into this. I know that's a little bit of much as a diagram, but you have to construct a data set that leaves the model no other options. When you're fine tuning a large language model, it is going to find the laziest path through the maze of data that you present it to, it, right? Any fine tuning exercise is essentially the model playing a game where if it does the right thing from your perspective, it gets a cookie. If it doesn't get the cookie. And if you want to train for this behavior that we were seeking of really actually attentively following the details of a content policy text, you have to construct a data set such that the laziest answer is also the right answer. And this is how we did that. We did that by crafting a series of policies for the same subject matter and applying them to the same example over and over and over, and then adding a label that followed from each of those policies where the labels contradicted each other. I'm going to repeat that because that can sound a little bit strange. It's a little bit hard to talk about out loud. But basically, you write multiple different definitions of harassment or sexual content or hate speech. It doesn't really matter. We did it for all of these. You take the same example and you label it against each of those different definitions with a binary outcome, a 1 or a 0. So all the answers here are commensurate. It either meets the criteria or it doesn't. But it does or does not meet the criteria for different reasons downstream of what you said in the policy text that constructed the category that you were asking the model to classify into. And you put all of that into a big pile, both for the single subject matter area that you're working in and across multiple subject matter areas. And you fine tune the model on all of that. Here's a decent example of this in practice. You can see here this sort of this politician's example that we're constructing different correct labels and sometimes the same correct label, but they're correct for different reasons, right? And so the only way that the model can win the game of guess the 1 or the 0 under these circumstances is to actually read the policy text and pay very close attention to what it is saying. Okay. This was the theory. But in order to do this, we needed to write a bunch of different content policies that contradicted each other, like a lot, like not just a few, not 3, not 5. We needed to write dozens across multiple different content policy areas, which is very hard. It's particularly hard to do well at a really high degree of quality. And even sort of figuring out what quality means in the context of a content policy is a sort of slippery and difficult idea. So we faced this problem of like, okay, we're going to try to train this model. We had this theory about how we're going to get this to work. How on earth are we going to create all this training data? So we had another problem to solve. And the sort of interesting unlock to get to scaling up content policy was understanding that while LLMs might not be very good at faithfully following the policies exactly the way that we wanted them to, they were very, very sensitive to differences in wording. And so you could take a policy text that, say, I wrote, and ask an AI to express an alternative version of the text that had the same length and the same format, but used different language to explain the ideas in the text. So not to change what the policy meant, but simply say what it meant again using different wording in substantially the same style. And then have an LLM use both of those texts to grade the same examples and look at cases where it disagreed with itself using a policy that should theoretically produce very similar outcomes. And it turns out that those mismatches are edge cases. In practice, if you've ever done this in industry, a lot of the ways policies get refined when they're deployed is that agents will use them, multiple different people will use them, and they will disagree with each other about how to properly interpret the policy text, giving you a sort of binocular vision on what different examples mean. This was a different way of getting at that same process of edge case detection. If we express the same policy idea in multiple language forms, the places where the same interpreter, the same language model acting as an interpreter, produced different verdicts were the places, it turned out, where the policy was insufficiently clear to bound the decision well. And we were able to use this process to scale up policy. And ended up producing, I think, something close to 70 different policy variants across 7 or 8 different policy areas, all of which were internally contradictory, building them into this big data set of essentially a thicket of policies where, again, if you took the corpus as a whole, the only way for a model that you had in the fine-tuning process to learn, to predict whether or not a given example met your criteria was for it to really, really closely pay attention to what the policy text said. And there was a pretty broad variety of differentiation within these policies. Some of them were very contradictory. Some of them were completely identical to each other, except had a single category or a single line removed, and the examples flipped that just fell inside that category. So it's not just differences in meaning, it's also differences in sort of the scale of difference between the policies to teach the model to both think about broad differences in form and very, very small differences in the details. That turned out to work pretty well. So we ended up with a 9 billion parameter model, which is small enough to run on your MacBook Air, albeit slowly, that outperforms many of the frontier models at the time, because this was from last year, while being 1% of their size. Which had a ton of advantages in practice because a much smaller model is something that you can run locally. It's something that we were comfortable open sourcing because it's not like the model itself is a particularly spicy or powerful machine. It also means that it can be deployed and used in practice at scale, which is an essential criteria for this being an actually helpful contribution for people in practice. So there are a few important constraints here in terms of how I'm thinking about this, sort of underlying premises. Because we're doing this binary labeling, you have to stick to sort of single category subjects, right? We weren't playing in this like, hey, I want a gradation of severities. The model can't do that kind of thing. You can use the model to construct something like that by simply writing multiple policies for the different severities that you want to classify for. And because it's small, you just run it multiple times, which is fine. But the model on its own is just telling you, is it in or is it out? Yes or no. You have to be very careful about how you write for this in terms of your language around sort of intention and meaning and goal and purpose. I sometimes joke that we're like industrializing postmodern English class. Like all the authors are dead. Nothing means anything. Nobody intended anything. The only question that we are asking here is, what does it say? If you want to model for intention or goal, you do that through how you construct the criteria. You don't ever ask the robot to guess what somebody felt in their heart when they wrote something. You ask, what do these words say? Very, very strictly, which can be a little bit difficult for people to stick to. And at least the model that we've open sourced is text only, although we do have a version internally that also is capable of working with images. It's relatively new, so we're still trying to figure out how well it works. Okay, so like cool, fine, we did all of this. But that method that I talked about, yeah, we were able to use it to scale up the policy production process, but it still took like a year, and the labor of a ton of labor for me and a bunch of grad students. Like, it was not fast. It just wasn't completely impossible which is sort of what I would have assumed before we had figured out the technique. And so we ended up thinking, okay, great, you've got this model. It can respond really quickly to well-written content policies. But how do you actually like systematize what we were doing in a way that was usable to other people? Because it worked, but it was like kind of janky. It was kind of expensive. It was slow. We were still reliant on external systems, which were very helpful, but were not exactly cheap to use. So from like a policy refinement point of view, we had this thing that seemed like it could be made better, that was really valuable. The critical insight here was to reframe what we were doing. We had been doing that policy collision process to look for edge cases, but another way to think of that is to understand that if you're building a policy and you have a set of examples that you're labeling against it, those things are not separate objects. You're really engaged in a fitting process between the policy text as an articulation of the values you want to try to use to categorize, and the individual decisions as played out on the specific examples you have. And those things are in dialogue with each other. We often hear people in industry talk about golden data sets, but the concept of a golden data set absent a policy that defines it just like doesn't mean anything. Skipping back to this, everything is meaningless and we define it in this exercise point of view. You have to work on them both at the same time. If you change a policy, unless you have an encyclopedic knowledge of the 1,000 examples in your golden set, you can't predict how that will actually play out in flipping the real examples, and you're probably pretty bad at predicting how you will feel about those examples flipping. And so instead of working on those things separately, you have to work on them together. And that realization from doing this over and over and over again led to a different approach to achieving the same end of policy optimization now that we had COPE as a model. Because COPE as a very small model meant that we could essentially brute force policy improvement by checking how well the model understood what you thought you meant by comparing its outcomes to your outcomes for that policy golden set pairing. So you could take a policy text, take a set of examples you'd labeled against that text, have COPE follow the policy, look at all the places where it disagreed with you, and that was another way of detecting potential edge cases where either your own decisions under the text of what you had written were incorrect, or the text that you had written to define what was correct was underspecified such that it was vague. And critical point here, COPE as a model, it's giving you a final token prediction, right? It's a language model, so it's printing out a 1 or a 0 at the end. And we were actually able to use the confidence of the final token prediction to help guide this process, because the places where the model is least confident but doesn't agree with you tend to be the places where you're most underspecified, because it's least clear to the model what you meant to say. It's the places where it's closest to changing its mind, for lack of a better way of putting it. And we were able to use this to put together a system that can very, very quickly help you revise policy texts and revise the labels that you have paired with them. It does not get you to perfect. I do not want to present this as magic, but it does get you to like 85 to 90% accuracy way faster than doing this by hand or doing this through training a set of humans. I'm going to show this to you all live really quickly here. Well, partially live. The optimization process where it does the thinking for you takes like 20 minutes. So I'm going to show you one that is already finished because we don't have 20 minutes to sit around here and watch it run. The watching it run part is not terribly exciting. It's just a loading bar. But before I get to showing that off, one, if you're interested in any of this, here are QR codes for going and downloading the model. It's open source. If you want to talk to us, that's the one down at the bottom. The platform we put together, this is the mild chill part of the presentation, but it's free. You can just go sign up and play around with this. The magic trick where we rewrite your policies for you part will eventually hit you up for money, but you can definitely use the relabeling part of it on your own to just mess around for as long as you want. And before diving into thank yous, so I don't have to switch back to the presentation, I wanted to just acknowledge all the folks that helped us get this far, because this wasn't just something that I did or Samid did on our own. There were a ton of people and institutions that supported this work, either directly or through free credits to do stuff with magic robots. So with that, I'm going to see if I can get into the other window here. Probably. There we go. How do I make this go away? More. Hide video panel or hide floating meeting controls. There we go. Okay, cool. So this does two things. I'm going to show you initial policy bootstrapping, and then I'm going to show you the sort of more completed process, but we're going to skip the actual optimization. So first thing we're doing here is we can just live generate a reasonably decent content policy for a given subject. I'm going to stick to something relatively non-spicy for everybody's eyes. So we're just going to do. Is this showing up on the webinar, by the way? Great. Perfect. So this actually lets us input examples. We can test, see how that classifies. OK, pretty reasonable. You could dump a bunch more stuff in here, which is important for later. But for now, we're just going to go deploy this, give it a second. It will then produce a policy text, which I'll show you. And then I'm going to squip to another version of a harassment policy where I've done the improvement loop against a set of labeled data. So this is what the policies this thing spits out looks like. This is downstream of a bunch of guidance about how to write well for COPE. You can just go generate these if you want to go play around with this. They generally have a series of sections. You'll get sort of a definition of terms section that defines really important words or concepts where you really, really care about what they mean. You'll get a section where we talk about the interpretation of language. This is guidance around how to read if under the rest of the guidance you've given, you're unclear. So like, what are your defaults? And then you define what is included in your criteria, what things should be marked as a 1, and what things that should be explicitly excluded, even if they meet your inclusion criteria. You can also put more narrow carve-outs into inclusions by actually writing them directly into the individual lines. These override everything above. So there would say, if this, but not this. And again, the background assumption here is nothing meets your criteria unless you explicitly say that it does, because we're purely constructing a policy out of nothing here. This optimization over on the side is the thing that I can show off if we upload some data, but we don't want to spend 20 minutes doing that. So for context, this is the F1, which is sort of a balanced number between precision and recall score of a sort of mediocre initial policy version. I ran the optimizer against the 500 results that I had uploaded. These are all different individual results that we've classified here. You can watch it do that classification in real time. And we ran those optimizers. So that's running through 500 examples using that specific policy text like right now. The system itself also came back with a bunch of suggestions about how to make the policy text itself better. You can get into the detailed criteria as well as some places where it thinks that I labeled incorrectly and that I might want to, according to my own stated criteria, and I might want to revisit those labels. It can get pretty subtle. The creating a new silencing and hostile directives category is kind of interesting. Goes sort of interesting directions based on what's in the data. You can apply that improvement through this, which I have already done. And if we switch to that new working draft, you'll notice the F1 scores jumped from the 50s into the low 80s in a single run. Now, you don't always get results quite that dramatic. Your starting point is usually a little bit better than 50%. And getting beyond the sort of upper 80s into the 90s can get hard, frankly, even for me with manual refinement. But it is a broadly working system to get you to pretty accurate classification for essentially any arbitrary criteria that you want. And this has implications both in trust and safety, but also, frankly, for any classification that you need to do on text. So with that, let's talk.
All right. Thank you. So, I'm immediately, my first thought is the future is not, in fact, model bullying. Uh, I'm going to
we
use that all the
we
time.
pre-bullied the
You
model for you.
pre-bullied the
Yeah.
model. So you got into this from a background in trust and safety, but I mean, I like how you ended on the sort of broad applicability of this to any sort of text thing.
Yeah.
Where does your imagination go next?
Oh, I mean, in terms of how you can use stuff like this?
Yeah.
Yeah, I mean, so we came to this from a safety-oriented interest, frankly, out of an urgent concern with figuring out how to use AI to help us deal with the problems that AI was going to create, right? It's going to make a lot of content, and some of it's going to be not awesome. And so it seemed to us from just like a scaling, keeping up point of view, you need to figure out AI, how to use AI to help you do that, or you're not going to be able to keep up. It's not like our historic systems worked well. And so that's how we came into it. But the thing we've ended up making is essentially an arbitrary category classifier. And if you sort of really zoom out and think about how much of the web is powered by sorting stuff into piles, like there's potentially a lot of applicability for this in things like feed ranking, in things like search optimization, or even like powering. I mean, like frankly, Google search is powered downstream of a bunch of category sorting criteria, very, very, very complicated ones that I would not claim Cope could handle right now. But you can sort of see where this goes as a proof of concept. And then on top of it, I think there's interesting novel emerging spaces around like quality assurance for things like MCPs or like Anthropic launched Skills over the weekend, which is super cool. If you haven't played with it yet, you should. Those are distributable. How do you know that they're not evil? Because just some random guy put it on GitHub. So there's going to be a lot of need for review of text objects, and having very lightweight language models that can do that for arbitrary preferences seems pretty broadly useful.
Yeah, it really does. So when you think about trust and safety, though, I think it kind of comes back to the idea that that it's a concept that I think, you know, an opinion that we share is that humans are particularly good at classifying traumatic. I mean, what you were saying at the very beginning, where it's like, oh, keep this entire corpus of policy into your head, and then view something that's like, you know, really blood-curdlingly horrible. Also do that at scale all the time. Are humans meant to be doing this? Is this a better way to go? And do we lose anything when we eliminate that person from the loop, or is it just broadly beneficial?
I'm pretty pro automation at this level of the decision-making process. And this was some of the prior talk I gave, and I didn't dwell on it too much here because I wanted this to be more of a how we do it. But I do not believe that I do not believe that we can realistically create a system where human beings do the amount of classification that we need to have done well in a way that is not immiserating. Like both that, I think the immiserating thing has been dwelled on a lot, right? There's been a lot of other folks who've talked about how content moderation can be traumatic for the moderators, and that is itself a sufficient motivation to try to achieve replacement there, right? There are some jobs that cannot be made good. They should just be made not jobs anymore, and that's actually okay. In the same way that we like stopped having people go into the hand smashing machine in 1855 London, like that was good, actually. But also in this particular context, this is basically a precision manufacturing job. Like what we're really talking about is the mass production of sorting stuff. And humans are beautiful and wonderful and magical and unique. And like, how many of you in this room can draw a circle freehand? I can't, right? Like we're not awesome. Some of us, a very small number of us, are very good at precision in very particular domains, which is very valuable. And like the folks who would probably be completely amazing at doing content moderation super excellently are like being hedge fund managers staring at Excel spreadsheets or something. Like it's just not a thing that we're going to be able to scale up through the bulk recruiting of people, particularly under the economic conditions the work is going to happen under, given the amount of it that has to be done. And so I think it's both good morally, but the results are almost certainly going to be higher quality as we get these systems dialed in. That said, you do still need human supervision at the level of what it is that we want, which is why these sort of policy revision systems, it's helping you get closer to what you meant to say, but it's always checking back in with you about whether or not this is what you wanted to say. Because it shouldn't be deciding what we want. It should be helping us figure out how to better express it.
So once you fine tune this and make it into a smaller model that's more sort of like compliant to the policy, does that have any safety implications? Do you worry about that at all? And I just turn everything into an apocalyptic
it's fine.
question, so I apologize. But
No.
does that keep you up at night a little bit?
Well, so we trained it so intensely for classification that we kind of ruined it as a language model.
Yeah.
So no, actually, because it really only does the one thing. It's kind of an interesting, like the race with LLMs has been towards general purpose technology, right? Everybody is aspiring to build the one robot that does everything. And in some ways you can see the argument I'm making here is like, yeah, that's cool as a way of creating a general baseline intelligence, but then like specialization is still useful actually. And this is just re-specialized back out into a very narrow particular domain. And we're caching in that specialization for being very small while still being very good instead of having to be very big, which gets you faster and cheaper and more environmentally friendly and all this other stuff.
So is the next path, you said images, video,
Yeah.
what's the next?
Yeah, we have a version that uses a multimodal model as a base that works on images. We are thinking through how we want to deploy that, particularly from so it's available to some of our customers on a preview basis because it's just like super new. We're also thinking through how we would want to deploy that into any sort of interface like this, less because we're afraid of the use of the model and more because if we're going to let you do policy refinement against a bunch of horrifying images, that means we're hosting a bunch of horrifying images. So like we just need to do some product work about thinking that through, but it's not actually an interesting model problem. It's a like, do we want to be doing that? If we don't want to be doing that, is there a way we can still be helpful and get out of it that we need to figure out?
Yeah, that's kind of what I was going to ask next. Like, is that the business you want to be in? Is training that? Yikes.
Yeah. So what's interesting with the model that is image capable is that we haven't done a ton of image classification to get that working. We've used a language and image capable model on our existing training corpus, and we're going to see how far that gets us. I assume we will probably need to do some amount of specialized image training, but because of how we're training this, we don't necessarily need to train in domains that people are using the model in for it to be useful. So a critical thing here, right, is like we trained across the 7 or 8 policy areas, but the model is capable of classifying in like totally random. One of my like fun examples is I do unicorns and unicorn related products, where it's like, is someone selling a unicorn? And then see if you can go convince the model to treat rhinoceroses as unicorns by defining your terms clearly enough. And like we definitely didn't train on that. And so you can get to technology that is usable for some pretty rough stuff without us directly building a corpus of that stuff using this technique, which is really, really neat. It's a little better in areas where we trained, but it's still very capable outside of those areas.
Probably any questions in the audience?
Curious about the 9 billion Curious about the 9 billion parameter decision. Like, did you try training a similar model that was larger, and like, how much of a quality decrease or not was there when decreasing to 9?
So 9 billion was actually our increase. We started with 4 billion parameter models because for a couple of reasons. One, constraints can be productive. So like, frankly, Sabid brought the size constraint to the table. I thought he was out of his mind when he said we want to try to target a model that small. 4 billion, it does work. We were able to get it to work with a 4 billion parameter model. It wasn't as sensitive around sort of nuance and detail. The multimodal version is 12 billion parameters and also can deal with a much larger token context. But a lot of that is just downstream of model improvement since we started doing this versus now, because small models are getting better so fast. We have considered training a larger model. We probably need to go back and do a dataset expansion project to get that to work. And given that this worked relatively well and our goals around speed, it just hasn't been a priority. We've looked at it, we've played with it a little, but our sense is we probably need more data.
Can I ask a follow-up? On explainability, is the output here a binary classification, or is it also reasoning that, cites the policy you provided it? And if the latter, do you still do you find the reasoning that is produced convincing, or is it still sort of vibey reasoning?
Right now, it is just the classification. Um, one of the things in addition to images actually on the what's next roadmap is there are a few things, but one of the things I'm playing with this fall is thinking through how we might be able to do explainability in a way that doesn't result in using a ton of tokens. Because part of the reason this is fast is it's just giving you yes, no. If you get yes, no, and by the way, here's like 3 paragraphs of reasoning, like that's going to slow things down a lot, even with a really small model. I've got some thoughts about like maybe we're trying to get it to cite chapter and verse in a sort of like section 1AB is why done, which I think is doable. We do also generate reasons as part of the broader system using larger models in a sort of agentic way that are doing policy review. So we can sort of retro construct reasons, but right now COPE doesn't provide reasons, Zentropy does, but that's only as part of the policy refinement process. Yeah.
You're the blue team. Can the red team use this to defeat you?
Well, so what's interesting about this is it's sort of a 2-key solution, right? Like probably if you studied it enough, I'm sure it has quirks, right, built into it. But how it's going to classify in any deployed context is a product of both the model and the policy text you are giving it to classify according to, which you don't need to tell anybody. And so, and if you find folks like figuring out how you're classifying and engineering around it, you can just update how you're classifying and it immediately changes the behavior of your classifier. So in a lot of ways, I'm not going to say it's perfect, but it's frankly a better situation than where we are today in a lot of ways.
I guess I've 2 questions. One, I'm just curious, like, why a company like Meta hasn't started this themselves as well, or maybe they have, but I guess that's just kind of a question. Like, if they have all the resources, it seems like it would be generally helpful. And then the other question is, I know, like also going based off of Meta, like that a lot of their content moderation policies have different exceptions for like minors versus public figures versus just like a regular adult. So I guess, do you think those classifications are helpful, or would this kind of seek to make it more uniform across those different divides?
So some of the policies we trained on do use categories like that insofar as they're manifest in the text. This as a machine right now just operates at the level of the text. You could use a system like this to do those kinds of exceptions, but you'd probably do it in conjunction with a rules engine where you just knew or used a separate specialist system to assert what people's ages were, and you combine those together. A sort of broader thing here, like we ended up doing binary classification for technical constraint and focus reasons. But I also actually do think it is better in this LLM sort of classification context to do just like single category binary classification because you end up with less confusion coming out of the model because they're non-deterministic machines. And so like if you have a judgment in your system that you can make deterministically, you should do that always because that will be reliable, and using a language model to do it is just introducing potential unreliability, right? So to me, it's a system of a bunch of specialist analytical parts, which you could use, right, with something like different judgments by age, where you've made judgments about the ages of the people involved, and then you're feeding in different policy texts for those different ages, is how I would tackle that. In terms of whether or not companies are pursuing these kinds of solutions, they are. I think there's less of an emphasis at a lot of the larger places on really small special purpose efficient models because they just have helpful only non-safety trained versions of their medium to big models that they can use to do this. And that's like kind of good enough compared to the amount of work it is to pull together a data set to be able to train this level of specialization. I don't think that's ultimately gonna prove to be good enough, and I don't think it's accessible enough to everybody except the very largest players, but that is kind of what's going on. And then also like large human organizations are slow.
Is that just a failure to imagine at that company? Like, oh, we have all these resources, so why should we do it more efficiently? Because it seems like self-evident that this is a better way to approach this particular problem.
Yeah, so I suspect folks are pursuing this, but aren't talking about it as publicly. Talking about improving your content moderation is not a popular thing to do
Fair.
right now. So that's probably not helping. Being chatty about this kind of subject matter in the details is also not a thing that companies generally do. So I would assume that it is happening. I know it is happening in some places without getting into where. But again, I think there's a little bit less of an emphasis on smallness and publicness, which I don't fully understand why that is. The other part of it is that there are a lot of people's jobs and internal empires tied up in managing the humans that do this today. And that's hard, right? Like any new technology, my understanding is that any new technology entering the economy, like the lag is often the integration into businesses as organizations. Far more than it is does the thing work. And I think we're kind of there on a bunch of these kinds of things.
It seems fair.
We have quite a few questions online, so I'll try to get to a couple.
Great.
So there are two sides of content moderation, protecting users from harm, this presentation, and censorship, not touched on yet. How does model tuning for censorship differ than for harm mitigation, if at all? And related, often users talk around term restrictions with euphemisms. Does this come up in either case?
I don't think it differs. I think one of the interesting things here, and we called this out in some of the, like, I've got a paper to finish editing about that's basically this, but with more diagrams and more words. And one of the things we talked about there is that there is definitely dual use potential here. This is a sorting things into piles machine. And you can do all kinds of stuff with things that you have sorted into piles for all sorts of reasons. So I don't think there's a difference there, and I think it's an interesting and valid question. I also don't know that it is really something that we can prevent at the model layer as a sort of team training these things. It's pretty hard for me to articulate a set of criteria that are presumptively illegitimate for someone to want to classify against. It's actually pretty hard, particularly when you think outside of just the content moderation space to the broader content classification realm. Like saying this pile is a pile that ought not to exist is pretty hard. It's the use to which the category is put where the problem arises, and that is beyond the level of what we can fight against in the model itself. Sorry, what was the other part of the question?
The other part was just mentioning that users talk around term restrictions.
Yes. So you can assert the definitions of the meaning of terms in the policy itself. That could obviously balloon to a really unhelpful degree. We haven't played with this yet, but I think you could see future versions of systems like this that are trained to pay a bunch of attention to databases in almost a sort of RAG-oriented way about what particular terms mean, which then means updating your understanding of slang as simple as updating a list. I'd also note that, again, like updating the 1,000 humans working in, working for Accenture on what all the slang means is not itself a foolproof. Like that doesn't work well today either. And so yes, there's a problem with this sort of approach now. It's sort of addressable today, and I do think as you play it into the future, it actually gets easier to address.
Is this on? Oh, okay. Hi, my name's Meg. I'm an MPP candidate at the Kennedy School. So I studied public policy. I came into HKS like very interested in AI harms, and I've since a little bit pivoted to more thinking about like how technologies like this can be used to make more efficient government services and the more efficient deployment of government services. But I have two questions, if I may. First is on far-right violent extremism. Could you see, right, a lot of people become radicalized online through like Discord chats or stuff that's happening in real time. Could you see this technology, I guess, being squared up in a way that it could be deployed in real time?
Yes.
Would that be useful? And then on a completely different way of looking at this, do you think that this could be deployed by like local and state governments for permitting? That's a huge issue going on with them right now, and they're trying to make that whole process more efficient. So just wondering your thoughts. Thanks.
Yeah, on the real-time deployment, like yes. So running on like an A100, so not even the largest GPU you can get, we typically have something like 200, 300 milliseconds of latency today through the API that powers the website, because we also have an API if you want to plug into it. And a significant chunk of that is network latency. Now that's not like fast enough probably for like a chat, real-time chat interface, but it's fast enough for a lot of things. And as small models get better and as hardware becomes more available and cheaper and better, like you're gonna see that gap shrink. So like we're pretty close to being able to use it in real time, and depending on what real time means to you, and we will get there. We have some customers that use our model to relabel data that they use to fine tune very small classifiers because they're extremely latency sensitive. And they're able to retrain those classifiers really quickly as things change because they can just update the policy, recreate the data set, refine tune the model. So like you can also do sort of a two-step thing today. In terms of the sort of local government or like permitting sufficiency, yes, although I don't know that COPE specifically is the right answer for that versus there is a company called SafetyKit who transparently helped us do the data labeling for this that uses GPT-4 and other large model powered systems to do like whole website analysis for like, are you in compliance with Visa's terms of service? And my suspicion is something with a somewhat bigger model that is maybe a little bit less specialized is probably better given the length of how long those permits are likely to be. But like the tool you're going to want to use is, I suspect, is going to be to some extent a function of the length of the content. There's also like an interesting question embedded in there in terms of what your criteria are and how we think about sufficiency, because the sort of underlying perspective here is very flattening in terms of what language means, and the law is not always written that way. And so I think there's an interesting encounter between how the regulatory codes are expressed and how interpretable faithfully they are by models that don't have any of the like embodied consensus that exists in the judicial system. And you would have to render that into text. So there's like an interesting thing there.
Test. So much about the trust and safety field is around the negative and reducing the negative, harm reduction, risk mitigation. Do you have any goals around, or do you see momentum around the positive of being able to help facilitate digital well-being or other positive pro-social outcomes?
So there are, it's not quite in the category you framed it, but there's some really interesting changes in how trust and safety works, which again was not like the dwelling point of this talk, that are downstream of having something like this. In addition to us not doing a very good job with classification today, content moderation is almost universally a terrible customer service experience, which is, it's a weird way to frame it, but comes out of my experience working at Airbnb, where Airbnb does live phone support because they have your money and you're in a stranger's house. And the degree to which serious incidents went well or badly, the degree to which that was determined not by the substantive resolution, but by the sort of emotional quality of the reception of the incident at the time of contact, is like really instructive as to how communication and delivery of information, even if it's information people don't want, really affects the way people respond to things. And if you just think about our content moderation systems as a form of customer service, they are like the most maximally alienating customer service systems imaginable, right? If you get like a brusque machine-delivered non-explanation that points to a list and it's like, you know what you did, it was one of these things, don't do it again. And then people are mad and we're surprised. And as we get better at this kind of classification and the explanation generation, you can imagine systems that are more tailored in their explanations, and potentially even systems where you're like, talking to the helpful customer service robot about why it thinks you probably shouldn't have done the thing you did, or maybe even should consider not doing the thing you were about to do, right? And some of that gets like creepy and weird. I'm not a user experience designer, but I think there are design constraints on how our trust and safety systems that have worked historically that are downstream of the fact that the only way to mass produce labels was by immiserating a bunch of people in a content moderation room somewhere. And that, in addition to being bad for those folks, imposes a ton of limits on how these interfaces can show up, most of which are terrible and kind of alienating. And if you can move away from that constraint, completely different experiences become possible. It's a little less the like human thriving thing, but at least being less negative.
Thank you for speaking to us today. I have two questions that are kind of inverse of each other. The first is, what's sort of the like blue sky application of this technology that would make you think, wow, I've done something really awesome for the world?
Sorry, I was giggling. I was laughing because one thing we've played around with was custom feeds on Blue Sky, ranked by this. So that's the obvious on the nose answer. We enjoy what we're doing. We want to continue to push forward this technology, but like more broadly, insofar as we help accelerate the pace of adoption of either these exact techniques or techniques that are in dialogue with the things we're pointing towards in the industry as quickly as possible, that will make me feel better, because the situation we have been in is bad and it is going to get worse if we do not figure out how to use these technologies to help us. And that's a bummer. And I would like that to not happen. I know that's kind of abstract, but that's the sort of, I want people to use what we've made. And even more than that, I want people to move in the direction that we're pointing.
And then my second question for you is, what's the red line for this technology where if crossed, if like a certain threshold of harm is crossed, you would consider or decide to shut this technology down?
I don't think that classification on its own is the thing that causes harm. And I don't think that we're providing anything that you absolutely could not do with stock models if you were determined and evil enough. And so from my point of view, this is a good area to work in because it is like pretty purely helpful. Because it's not like the models that come out the other side are just not useful for anything other than classification. And so if you're taking a base model that's pretty all-purpose capable, if anything, we're narrowing its ability to do other kinds of harm from a technique point of view. And so to me, your question sort of collapses to, are there kinds of classification that could become so ubiquitous that I would feel like pulling the plug? I mean, one, it's already open source, so we can't on some level, but two, I sort of don't think that sorting as an activity fits into that way of thinking about things. I don't know, maybe it's not a satisfying answer.
Hi, thank you so much, Dave. This is super interesting. I've just been thinking about the organizational context about how this might be deployed and sort of the costs and benefits of doing it with current models and the way it is now. And I've been thinking a lot about the sort of productive friction around culture, as this is sort of one of the issues about automated content moderation in general, is that it sort of slows, well, it doesn't know culture in the same way that like people do. And I'm curious about one benefit of this, right, is it's super fast. It can be automated at scale, but I'm wondering if it like could preclude some of those cultural conversations about edge case content, or just sort of bottom up, like moderator-led movements around certain kinds of content, right? Like I'm thinking about like Napalm Girl or breastfeeding or whatever. And I'm wondering if just you've thought about how it could be deployed within organizations that preserve some of that friction in like a good way.
Yeah, it's interesting. The examples you cited, I laughed about because I was at Facebook for both of them. In both of those cases, the cultural friction wasn't moderator-led. It was elite-led in the face of and frankly ended up imposing difficulties on moderators that were difficult for them to cope with. So like the Napalm Girl, if folks don't know, this is the Pulitzer Prize winning photo of a girl who'd been subject to a napalm attack in Vietnam. Very, very famous photo. If you do not know that the photo won a Pulitzer Prize, it is a non-consensual nude image of a naked child the government just committed a war crime against. And so if you're viewing it in the sort of flattened way that systems like this think, I'm pretty sure we, for several different reasons, want that photo to be on the bad list. The reason folks don't want the photo to be on the bad list is because it's famous, which is not a property of the content. It's a property of our social feelings about the content. You can do things to make that exception. But at the time that the Napalm Girl controversy happened, what ended up happening was just like every moderator in the world had to look at that photo and memorize it to give it its own special status, which is not a scalable process, which was the whole problem. And so the Napalm Girl story in a lot of ways actually influences my thinking about why things like this can be helpful, because it makes doing things like having multiple separate rule sets for subtly different categories of content actually a practicable idea, which is hard to do with sort of moderators. On the cultural differences point of view, one thing that systems like this mean, because they're open source, they're small, they're relatively cheap to run, and frankly, because we're trying to be open about how we built at least some of the baseline technology such that others can go build on top of it, is that it potentially opens up. You can think of what we're doing here as miniaturizing the capacity for scaled content moderation in a way that makes it accessible to more than just gigantic rich companies. Like the bureaucratic difficulty of organizing doing content moderation at scale is as much, in my view, a force that centralizes social media as the lack of data portability, which has received way more conversation, right? Like the random guys who run their Mastodon servers cannot adequately moderate those servers if they become popular. They simply can't. And technology like this maybe makes it more possible for them to do so, which also means that moderation from different standpoints, from different subreddit owners, from different Discord owners, from different cultures, potentially becomes more possible if you can sort of like shrink the tools in the same way that like when we only had mainframes, only IBM had them. And now everybody has a pocket computer because it's small and cheap and ubiquitous enough. And that there is, I think, something of that, we hope, in this.
Great. So we are at time. I'm going to take one more question.
Thanks very much. I thought the point you made about the well-being of content moderators was an important one, and I'm glad you made it, right? That like there is a North Star here where less people have to look at horrible stuff, and that like significant numbers of people's mental health is better as a result. And so
my therapist says I'm totally fine.
well, in terms of a blue sky, like positive output, that could be one.
Yeah.
In that world, presumably humans still need to provide ground truth labels for content. And so curious if you could speak to what does the fully automated or quote unquote fully automated world look like in your view?
Yeah, I think you're going to want, I think it moves to a world where humans are, I think it in some ways looks closer to what we already have in some of the like spam and like government state-sponsored actor abuse networks, where you've got experts who are using a bunch of automated scanning systems to go sweep up networks of content, where they're applying a standard, but they're also like adapting how they're looking in real time. And if you can divorce the standards as like the law from the standards as the seeking instrument, I think this opens up a world where you've got a smaller, relatively smaller group of people, or maybe it's not a smaller group of people, but they're more highly empowered, covering like larger amounts of subject matter, but not doing the sort of stare into the Clockwork Orange machine all day as your job kind of version of this. And it's an underrated part of the sort of content moderator health thing, mental health thing, that it's not just the activity, it's how diversified the activity you're doing is and how empowered you are structurally and economically in doing it, all of which goes into the stew, right? Like I worked as a content moderator as an employee at Facebook in the office in Palo Alto. So I could go to Q&A and yell about things, right? And frankly had career path and like other things to go do. And that is a very different set of circumstances, even though I was still looking into the Clockwork Orange machine as like part of my day, right? And so if you can change how much control people have and the diversity of what they're doing, yes, there's still going to need to be human sort of agency in steering these systems. I think we want that. But that recontextualization and repackaging of the work such that a lot of the sort of most grindy part of it becomes something closer to a data query, I think that helps quite a lot in sort of reframing how the activity encounters people.
Okay, great. Thank you both so much. Thank you.
Thank you so much for coming. Shelby, thanks for keeping us on time.
Oh yeah, we're a little over, but we're good. I think that was a great conversation, great place to end. I do want to say we have more events in the speaker series coming up, so please follow us on socials, go to our website, our newsletters, we'll be posting about those. We also have an event tomorrow, 4 to 5 at Ames Courtroom with New York Times journalist Kashmir Hill. And we have Meg Marco facilitating with Jordi Weinstock, who's a BKC senior advisor. It'll be on AI sycophancy and the law. So hope you join us. Thank you.
Tell Cash I say hi.
Well, come on by.
What is it?
It's 4 o'clock.
I'm getting on a plane.
You're going
I'm
to be on
flying
a
home.
plane. All right. Well, it's